Hey, and welcome to Chemistry. I am Ernesto, one of your student tutors, and before we move on to the topic of the video, I'd like to define what chemistry even is. When I think of chemistry, I think of the basic stuff related to it, like explosions and changing, the color of fire, different colors, green, for example, and that is what chemistry is. Chemistry is a study of why matter changes, and this can help explain things from things as simple as understanding why freezing water turns it into ice to understanding how medicine works on the human body. Chemistry explains a lot of things that happen on a daily basis and helps us understand why a lot of things happen. So yeah, just wanted to go on a little tangent and wanted to explain what chemistry was. Now we'll move on into the first lesson, which will be particle behavior. So, to begin, one of the things that we know about the universe is that everything is made up of particles. Although we can't see them, each object around you is made up of millions of particles, and each particle is constantly moving. So, the three states of matter that we're going to be focusing on today are this. So, the three states of matter that we're going to be talking about today are solids, liquids, and gases, and we're going to be seeing how the particles move in each state of matter. So now the question that I want to lay down today is, do the particles inside of states of matter, such as a solid, act the same as particles in a liquid? Let's first take a look at a solid, for example, an ice cube. Just by looking at it, I can tell that the ice cube is a solid because I can pick it up and it won't change its shape. Let's note that down as our first observation. So we're going to say doesn't change shape. Alright, let's note that down as our first observation. The next observation that I can make is that the ice cube does not physically change when I pick it up. This means that the ice cube has a definite volume, which means that the ice cube takes up space and the amount of space it takes doesn't change. Yeah, and so one example is this eraser. So as we can see, the eraser is a solid, and even as I'm holding it, it does not change its shape and it maintains its form. So even if I were to move it around, if I were to do anything, just like change the direction that it's in, the eraser will stay the exact same volume. Which means that it'll take up the same amount of space that it took before and it won't change. Unless I do something physically damaging to the eraser, it will stay the same. Alright, so now we can move on to drawing what the particles look like in a solid. So to make a visual of how particles move, let's say that these circles represent the each individual particle in an object. Just to save space, because there's millions of particles in each object, I'm going to draw how 4 particles would look like in each state of matter. In a solid, particles are very closely packed to one another, and because of the way that these particles are closely packed to each other, they don't really move that much either. At best, what ends up happening inside is that the particles just shake around. To show that these particles are shaking, what we do is draw these sort of shaking lines that help acknowledge that although these particles are very close to each other, they are still in motion. Looking at the particles helps explain why solids maintain their shape as well. Sorry, I just realized that I made a mistake with what I wrote up there. Let me fix that real quick. It should say definite volume instead of definite shape. Yeah. Technically, the doesn't change shape also means definite shape, so I basically wrote the same thing twice. No big deal, I can change it, it's fine. So this explains why I'm able to pick up something like a eraser, for example, and see why it doesn't move around. If the particles are all closely packed to each other and they really only shake, there's not enough energy inside of the particles to really move away from each other. So they'll kind of just like maintain that solid form. Now we're going to move over to liquids. Let's pretend that we decide to heat up the ice cube by leaving it in the sun inside of a cup and let it melt. This will change the ice cube from a solid to water, which is a liquid. And what ends up happening inside here is that because you're adding heat to the ice cube, heat is actually a form of energy, and as the heat comes into contact with the particle, the energy inside of the heat will actually be absorbed by the particle, and the particle will begin to take in that energy and move around more. The way that I like to think about it is that, one day you wake up tired and you don't really want to do anything in the morning, so you decide to take some coffee, and it gives you energy, which helps you move and be more productive throughout the day. It's the same thing that happens with the particles. The coffee is the equivalent to energy for the particles. So the more energy you give particles, the more they'll move around, and same goes vice versa, where the less energy you give particles, the less they'll move around. Now let's go back to our water example, and let's define what the physical traits of a liquid are. So a liquid is an object that can change shape. Let's write that down. Liquid changes shape. All right. Okay. And actually, because they can change shape, they end up taking the shape of the bottom of the container that they're in. In a cup of water, if I were to, or one way to show that they take the shape of the bottom of the container is that if we have a cup of water and I tilt the cup, we could see that the water also moves around to take the shape of the bottom, And another thing that we can note is that although a liquid can change shape, it still has a definite volume. It still takes up space like a solid, and unless I were to do something to the liquid, for example, if I drink a little bit of the water, or if I dump some of the water out, the amount of space that it takes up will stay the same. So going back to our last part, as a solid changes to a liquid, the particles inside start to move apart from each other. So when we were to draw this, when we draw the way that the particles behave inside of a liquid, we'll also depict that in the image. Only this time, we won't be drawing the shaking lines that we did with the solid, since the particles are no longer shaking. Instead, they are moving around. So to indicate that the particles are moving, we'll draw these double lines that basically show that the particles, or that show the speed of the particles, that show the speed and the direction at which the particles are moving. The direction of the particles doesn't really matter all that much when we're drawing them. I just like to draw them moving in different directions to show that they can move in these directions. They're not limited to just one way. They can move any way that they in any direction. Okay. Now moving on, let's add even more heat into the water. After adding enough heat into the water, we know that the water will eventually begin to boil, and as the water boils, you create water vapor, which is a gas. So instead of starting off with the physical traits, let's start this one off by drawing how the particles move inside of a gas. So it's basically going to look very similar to the way that the particles inside of a liquid move, only that the gases take the shape of the entire container instead of just the bottom. So I'm just going to draw the gases everywhere and draw the movement lines. This time, we're going to draw the lines a little longer than the lines we drew in the liquid to show that they are now moving even faster. So one thing that we can note from this is that the longer the lines that you draw on a particle, the faster that the particle is moving. Now, let's look at the physical properties of the gas. Gases, like liquids, can change shape easily. So let's write that down. See. Gases can change shape. Because of the speed that the particles are moving inside of a gas, gases actually change shape constantly. So I know that the lines don't, just indicate that they're moving faster, but actually the particles inside of a gas are moving really, really fast. One difference that gases have compared to solids and liquids is that they don't have a definite volume. I'm going to write that down as the next one. So gases have no definite volume. And what this really means is that gases don't have a amount of space that they take up that is constant. One way that I could show this is that if I were to release water vapor from a container out into a room, the vapor would just disperse around instead of staying in one big clump of gas. The particles inside of the gas are actually moving too fast in random directions, so they'll actually have a hard time sticking together, and they won't if they aren't in a container. Because of the constant movement that the gas particles are in, the volume also changes constantly. Great, so now we have an image of all three states of matter affecting particles, and we're going to fill out the table at the top. For the first two columns, we're just going to fill them out by rating the states of matter from highest to lowest on the two different subjects. We'll start off by rating the state of matter on their forces of attraction. Force of attraction is just referring to the closeness that each particle is to each other. The closer the particles, the higher forces of attraction they have. From looking at the three drawings of each state of matter, we can tell that solids have the most force of attraction between each particle because all particles are very close to each other. Moving from there, we can see that liquids come next, with the particles starting to move around but still being relatively close to each other. And then that means that the state of matter with the lowest force of attraction ends up being gases. Even without looking at the graphs, we can tell which state of matter has the highest force of attraction based off the amount of energy that each particle has. Particles that have more energy tend to move faster and further distances than compared to particles with less energy, and because of this increase in speed and direction, they also don't stay close to each other. So particles with less energy actually tend to have higher forces of attraction than particles with high energy. Now we're going to move on to ranking the kinetic energy of each matter from highest to lowest, and we'll start off by defining what kinetic energy is. Just in case you forgot, kinetic energy is the amount of energy that an object, particles in this case, are releasing out. The more kinetic energy that particles have, the faster that the particles are moving. With this, we can tell that the gases actually have the highest amount of kinetic energy because they're moving the most, and then followed by liquids, which are moving a little less, but they're moving more than the solids, and then the particles with the least amount of kinetic energy are solids. Great, now moving on to shape. We were supposed to define the physical characteristics of each state of matter here, but we've already done that on the side. Just a quick recap, solids don't change shape and they have a definite volume. Liquids can change shape, but they also have a definite volume, and gases change shape and have no definite volume. And for movement, it's actually referring to how the particles would look like inside of each state of matter. And look at that! We drew the visuals of the particles for each state of matter already. So let's just draw those real quick onto the chart. So we've got our solid, which uses the shaking lines to indicate that the particles are just shaking around. We got the liquids, which use double lines to indicate the speed and direction of which the particles are moving. And we've got the gases, which have even longer double lines to indicate that they're moving even faster, and also as well to indicate the direction in which the particles are moving. And with that, we're done with particle behavior 1. Woo! Yeah, so that's all for today. We will have a worksheet down in the description for you to review what we learned today. So yeah, definitely check that out. And the next video, we're going to be continuing on particle behavior, but this time we're going to be focusing on gases. So hope to see you there.